Hey, Chris, so those LangServe deployments, they just work, huh?
They just work, Greg.
And when they work, we get like a sweet LangServe playground to mess with, don't we?
We sure do, Greg.
Right on, dude. Well, can you go ahead and show us what it looks like when this thing's all said and done?
Absolutely, yes. This is it. So the idea is that using the LangServe tool, we are able to create an endpoint for our newly created chains, and we're able to use that endpoint through this playground. So in reality, what's happening is there's some endpoints that have different methods we can call, but the playground is going to help us call those, and it's going to show us the information we're going to see. So you can ask questions. This is a spoiler for what we've done the application with, but you can ask questions like, how would I add a custom chain as a route in LangServe? And you get this, this response, kind of typical string response. The answer is correct, which is definitely nice. And then we are going to also be able to see all of the intermediate steps of our chain by default. So these are all things that each step happens, one after the other, and we get this entire thing kind of, quote unquote, for free out of the box. So a very powerful tool, very powerful both for prototyping and then moving to production.
Man, that is super dope, man. I can't wait to see how all this comes together step by step as we build it up from scratch, man. We'll see you back in a little bit to dig in. All right, everybody, welcome to today's event. My name is Greg Loughnane, founder and CEO of AI Makerspace. That was, of course, Chris Alexiak, the LLM wizard, CTO of AI Makerspace. And you'll today learn all about LangServe, how to build REST APIs. And what we'll do is we'll actually build a RAG application with Mistral 7B, piece everything together. And by the end of today, you'll really understand how to build and deploy an LLM application all the way at the edge of kind of what's possible today. All right, let's go ahead and get right into it. So we're talking LangServe, we're building with Mistral. We always want to set off the day and align our aim for the session. We just mentioned it briefly, but we're looking at LangServe. We're looking at how to build these REST APIs out of our LangChain applications. That RAG system with Mistral 7B is going to be built using the underlying LangChain Expression Language, LCEL, and we're going to deploy our chain to an endpoint. Ultimately, we'll have that nice playground that we can use, but also share with others as well, which is super cool. So first we'll talk LangChain, and we'll kind of weave this together today, talking about Mistral, talking about RAG, and then ultimately getting into our build. We should have some time for questions at the end. So we look forward to you guys sharing your questions with us and digging in a little bit deeper when the demo is through today. So first, to get an introduction to LangServe, we want to kind of get the introduction to LangChain. We want to build this up one step at a time. Of course, LangChain has been putting out a ton of great content. These are the deep learning short courses that we've seen. Would highly recommend that you check these out as you're kind of getting into LangChain and getting started. But LangChain fundamentally, from the beginning, has always been about combining LLMs with other sources of computation and knowledge. This was sort of top level docs day one of LangChain, or at least day one of Series A LangChain. And, just not long ago, just a month or so ago, we were seeing this sort of language in the documentation where LangChain is sort of getting more and more specific about what it is they're aiming at. They're getting clearer and clearer with their language here. And they sort of called out, hey, we're not only looking at building LLMs and building with them, deploying those things to endpoints. We also want our systems and our tooling to be able to build, quote, data aware sort of applications and also agentic applications. Interestingly, as we've continued on, they continue to sort of refine this language. So we can sort of think of this data aware and agentic idea as more, in sort of the parlance of today, we can think of it more as context aware. This is the latest version of their documentation, where we're talking about not sources of information and knowledge, sources of data. We're talking about sources of context. This is very important as we talk about RAG systems, which are sort of the name of the game today. And then sort of replacing this word agentic with simply reason. So we want systems that are aware of context. They put everything relevant in the context window, and they connect to the most important pieces of context. And we want them to be able to reason. So in context learning and ultimately reasoning. So we'll leave reasoning for another day. But for today, we're kind of going to try to build up this idea of LangServe from the bottom here. This is sort of the overview of LangChain. We've got a ton of individual pieces that we'll sort of walk through as we weave this together. You see, we've got LangChain Expression Language, we've got models, retrieval, chains, and ultimately LangServe up here near the top. We're looking forward to covering LangSmith in an event next week, but for now, we're going to sort of build these up one at a time. The chain is sort of the fundamental thing here. We're building with chains. We're chaining things together. We're connecting stuff to other stuff. This isn't crazy. It's just this idea, this abstraction of connecting one thing to another and then creating a sequence of things connected to one another. Of course, you can get into that reasoning and agentic feel to sort of get a little more complex. But in the simple case, you're sort of connecting things sequentially. And the way that we're doing that at a base level today is with the LangChain Expression Language, or LCEL. And LangChain Expression Language is a really nice, elegant way to compose chains. And a couple of the things that are important to note today about what it does and why it's useful for us and what we're building with LangServe is that it allows us, as Chris showed, to sort of access these intermediate results throughout the chain. This is very, very useful as we're interested in how things are actually flowing through our application. And this is very, very important, especially in debugging and trying to figure out exactly how to optimize performance and utility of our applications for our users and stakeholders. And then additionally, this sort of input-output schema is also an integral part of LangServe. So you can use this to sort of validate inputs and outputs. And this is, outputs classically, we're talking a lot about calling functions, and we're talking a lot about JSON formatting, and OpenAI has just released JSON mode. So there's a lot of real interest in output schema. This is especially important in those agentic reasoning systems. But fundamentally, this LCEL sort of was built with deployment as well as production and operating in production in mind. So integrates perfectly with LangServe and with LangSmith. And as we heard, it just sort of works very nicely, very easily if you compose your chains and you go ahead and deploy them. So very cool to see that. Now, as we get into composing chains, it's important to sort of understand there are a few core aspects we want to leverage from this input and output of models. We're going to look at model and prompt here closely, but we also sort of want to understand that there is this example selector and output parser. The example selector is if you have many, many examples. The output parser is, of course, again, focused on this sort of making sure the output is of the format and type that we want it to be. So, if we kind of just go back for a second to the classic rules of prompt engineering, how to do it well, we want our instructions to be super clear, specific. We want the context that we provide, at a system level and within our prompting to be very, very clear. We want the LLM and our application to know where it stands, how to behave, what kind of flavor of responses and emotion of responses we want from it. And of course, within RAG systems, we also want to augment that prompting with retrieved context from our own sources of data and from our own proprietary information. And then again, as we get into sort of one-shot, two-shot, few-shot learning, or giving examples, this is where something like the example selector would come in. And then the output format is, of course, very, very important today. So focusing in on models for a second, we want to think about this chat completions model idea, originally kind of released by OpenAI, this kind of chat style model, this sort of 3 different roles of chat style has kind of become the industry standard here. So instead of simply in message, out message, like you would get in a single interaction with an LLM, what you're rather going to use is you're going to use sort of an input of a number of messages, and the output is the next message in the sequence. So here's the classic example. If we look at the 3 different sort of roles here, we've got the system level role, the user role, that's you or whoever's using your application, and the assistant role, that's either your ability to act as the assistant and give sort of a one-shot, two-shot, few-shot set of examples, or this is actually the AI providing the next chat model response. So these roles, they are true in OpenAI as they're true in many of the chat models that you would pick up off of Hugging Face, including Mistral. So the system user assistant schema for actually inputting information into a chat model doesn't go away. Here's an example from the Hugging Face docs. You're a friendly chatbot who always responds in the style of a pirate. What a classic. So that's sort of the system level. Often you'll see you are a helpful assistant in instruct-tuned models sort of baked in here. And then the user is going to engage with a question, engage with some sort of completion task. How many helicopters can a human eat in one sitting? Matey, I'm afraid I must inform you, humans cannot eat helicopters. On and on the pirate goes. So that's sort of the assistant responding in this case, although you could also act as the assistant and continue the chat. So this is important because in LangChain, as we build chains, we want to understand we're still leveraging the system user assistant message schema, although we call it something a little bit different. For these chat models or for these instruction tuned models, we're going to generally be leveraging this. And for the Mistral 7B Instruct v0.1 we use today, we will also be leveraging this. So the system human AI message is the terminology we want to get clear as we pick up LangChain as a tool and start using it. We can prompt Mistral. Here's a quick example. Without a system level prompt here, this is actually from the docs today on Hugging Face, is the user says, hello, how are you, assistant? I'm doing great. How can I help you today? And then we sort of see the user continuing the discussion here. I'd like to show off how chat templating works. Look at that. And I think the interesting thing here too is that as you sort of mess with the chat templating at the intersection of sort of Hugging Face and LangChain, you'll start to see that depending on how the chat model or the instruct-tuned model was actually instruct-tuned, there might be a slightly different template used to engage the model. In this case, we've got the tokenizer adding the control tokens, the stop-start sort of tokens on this line here. And this is, again, because Mistral was trained with these tokens. So, speaking of Mistral, let's take a little bit of a closer look at Mistral. They've been in the news a lot recently this week, so it would sort of be remiss if we didn't go here for a minute. Mistral AI is that OpenAI competitor of Europe, is sort of the way people are thinking about it right now. They're on a mission to push AI forward. They want to really serve that open community and, of course, their enterprise customers. And I'm sure that we'll see more and more good stuff coming from them. It's absolutely phenomenal. They just raised a $415 million Series A, which is just completely absurd. And this is 6 months after a $112 million seed funding round. So, I mean, they're over $500 million here within the last calendar year. Just crazy what these guys are doing. Co-founded by Google DeepMind and Meta alumni. They're really doing some awesome stuff. Even just this week, as they announced that Series A, they released endpoints, they released Mixtral. Just as a quick intro to this, you'll notice their endpoints, state-of-the-art semantic embeddings, powers RAG applications. That'll make a lot of sense by the end of the session today. And the generation piece, this is more like that GPT API that so many of us are familiar with from OpenAI. So really cool to see this coming out. Of course, Mixtral came out. We talked a little bit about that in a session yesterday. But for today, we're really focused on Mistral, this 7 billion parameter dense transformer. And Mistral is still just straight up crushing it. Mixtral is cool, but there's some things to be figured out with the mixture of experts models right now. If you're going to pick up a tool off the shelf to build with an open source model, there's really very few reasons not to just pick Mistral 7B. That's why we're picking it today. Great for low latency, all good at a lot of different kind of things. Apache 2.0 license, as the models coming out from Mistral are. And we've seen that it's sort of taking things to the next level incrementally. It's faster inference than a lot of the models in the same sort of weight class. And this sliding window attention is sort of an improvement on flash attention. So we get even faster processing time for longer sequences, resulting in less cost. And most importantly, Mistral still crushing the leaderboard for OpenLLM leadership on Hugging Face. Very much crushing it. You see, these are all Mistral 7B models tuned to try to, continue to work their way up the leaderboard. So punching well above their weight class. Again, Mistral coming in, crushing it. So this is the one we're picking up today, and it uses a chat style model. What we want to talk about next is we want to talk about a little bit more LangChain. So as we go back to the basics, LangChain is all about chains. So we need to go ahead and build chains. And the way to do that, again, is with the LangChain Expression Language. It's very easy to build your first LLM chain by combining a chat model and a prompt. That's sort of the simplest possible chain. This is the classic syntax, and this is the LangChain Expression Language syntax. A little more elegant and a little more scalable and useful in production as you get into LangServe and LangSmith. Now, since we're also building a RAG system today, we need to go ahead and address this retrieval component. It looks like there's a lot here, but really all these things are required for RAG. And so as we talk about retrieval, we're really talking about sort of this scaling up of the complexity of our applications from prompt engineering on and on to even more complex and useful applications that include RAG and augmenting your prompts with your own data. And so, just as a quick review, RAG is all about reducing these hallucinations by allowing LLMs to make sure that we're fact checking them so they're not providing these false, confident responses. Fact checking is the answer, even if all reference materials aren't necessarily perfect. Having a reference material is better than not having a reference material. This is the basic idea of RAG. We want to find references. We want to add those references to the prompt. We want to improve our generations based on those references. At AI Makerspace, we like to think about RAG as being broken down into two different components. One is dense vector retrieval, and one is in-context learning. As we've talked already, LangChain is very much aligned with this idea of being context aware, putting things in the context window. This is what in-context learning is all about. And, as we get into retrieval, we want to really keep in mind it's very simple. We ask a question, we search a database of our stuff to find stuff that's similar to the question, and then we return that as our references. So to create that database, we're going to split our documents into chunks. We're going to create embeddings for each chunk. We're going to store those embeddings in a vector store index. That's going to allow us to then have this backbone for our retriever that's going to wrap around the index so that we can ask a question. We can then get some embedding representation of our query. We can look for similar things using a similarity, a nearest neighbors approach, like a cosine similarity in our vector store, and we can return the right context. So the way this kind of looks all together is we ask a question, we look for similar stuff to the query in our vector database. We then go ahead and set up our prompt template for RAG, which is something like use the provided context to answer the user's query. You may not answer the user's query unless there is specific context in the following text. If you do not know the answer or cannot answer, please respond with I don't know. And what we'll do is we'll take what we find similar, we'll shove it into the context window, we'll put all of that into the chat model, and we'll get hopefully a better answer. So the way that we can think about this is, again, this dense vector retrieval process combined with this in-context learning process, in the context window learning, you might say, and this is the basic RAG setup. So we're going to take a close look at the models we're going to choose now, but do note that the other side of the LangChain prompt templating is the RAG template. We need to make sure this is also included in there. The template is not just the system user assistant level templating. And finally, when we talk about creating that vector store, we're talking about creating our index. The most common type of index is a vector store. The index is simply a way to structure our documents so that we can interact with them. And we already talked about embeddings. We already talked about similarity. It's just a database. And so putting this together, what we need to do to build this vector store is we need to load docs. We need to split text. We need to create embeddings. We need to create the vector store. And then we need to do the retrieval. And this is why when we look at the overview of LangChain, as we head into LangServe, we see retriever, document loader, vector store, text splitter, and embedding model. So we're simply putting all of this together to build out a RAG system. The one we're building today, as we've seen already, we're going to ask a question, something like, how do I add a custom route to a LangServe application? We're going to create a vector database using LangServe documentation. That's what we've decided to do, sort of meta LangServe today. And we're going to leverage the Facebook AI similarity search vector database for this, a great open source solution. We're going to return any relevant context. And as we already saw from Chris, we can actually get not just good responses, but correct responses that will help us code our application. So this sort of LangServe RAG flow that we're going to move through, we're going to search the LangChain documentation for the top K resources. We're going to add those specific, we're going to be able to ask specific questions related to the content, and then we're going to be able to return the appropriate context in the most context-aware way to build out our LangServe application. So today's build, again, is going to be associated with leveraging the LangServe docs straight up. These are good for RAG systems because it's very rich content, and they do have a great search mechanism on there, but you know, it is even a little bit more powerful if we can condense it automatically into the most relevant information. And there's a lot of tools you can use to try to take this to the next level, tools even within LangChain, like re-ranking, like really optimizing the retrieval for maximizing information and minimizing redundancy. But generally, any sort of rich content blog, you'll find could be improved on the way search is done. And, so we decided to sort of show the LangChain and LangServe specifically docs today. The models that we're using are number one, of course, Mistral 7B Instruct v0.1, and the UAE large V1 embeddings. They're at the top of the massive text embedding benchmark leaderboard today on Hugging Face. So we went ahead and picked that one up. Finally, we're ready to dive in to see exactly how to build this thing. We're pumped to sort of see how all of this comes together. We even get this really awesome, satisfying output when we finally type LangChain serve, as we'll see from Chris. I'd like to welcome back up to the stage to walk us through this LangServe and Mistral application. Over to you, Chris.
Hey, thank you, Greg. Yes. Okay. So this is probably the best way, I would say, to move from your your prototype or your chain in your notebook to a production environment. It really lightens the lift that you need to do in order to get this into a containerized format. So you'll see here that it does come with its own container. So, once you have this repo, right, with your chain in it, I mean, you can deploy this on any web service that you want, GCP, AWS, it doesn't matter. Azure, once you have the container, that's all you need. So I will share the GitHub link so that you can look at the repo if you wanted to, but if not, that's fine too. The basic idea here is that when we talk about the LangServe component here, really what we're talking about is wrapping our existing chain into a FastAPI server. The FastAPI server is going to act as a backend to allow us to access our chain in ways we would expect through the through an API. Now, this is something that you could do, of course, yourself, of course, but it is going to massively lighten the load to use the LangServe method, because it's going to deal with all of the kind of particulars of creating the various endpoints that we should hope for and need to allow us to stream information, to allow us to get intermediate steps. And then, of course, it has a baked-in integration with LangSmith, which we won't be focusing on today, but is powerful. Yes, as someone noticed in the chat, it uses poetry as the environment manager. So the idea is that we are going to kind of bundle up what we're doing into a poetry environment, and that's what's going to be keeping our dependencies straight. So let's look at what we have to do. First, we had to create an index. We don't want to be indexing while we're using the application. So this is just going to very simply take the repo from LangServe. It's going to load it using LangChain's Git loader. And then we're going to split it. And then we're going to send it to our embedding URL for our Hugging Face. We're going to enter our token, and then we're going to split. Due to a limitation in the implementation of the Hugging Face embeddings module in LangChain, we do have to manually batch in sizes of 32 just to make sure that we don't run into any errors. But the idea is, once we've embedded all of our information, we can go ahead and shove it into a Face vector store. And then, of course, we can save that locally so we can leverage it later. So you're seeing at this point, we have this embedding URL. So what's going on there? Well, this is powered by a inference endpoint through Hugging Face. So basically, all of the models we're using are served through these inference endpoints hosted by Hugging Face. So we have these URLs, which we can point to. That's going to be our model, right? So we have our Mistol model, and then we have our embeddings model. So our embeddings model is running the UAE large V1 embeddings. It's running them in this text embeddings inference container, which is an optimized container for embeddings. The entire idea here is that we want to be able to, host these models in a place where we can manage scaling and everything like that. And so we can do that using the Hugging Face inference endpoints. Out of the box, this is going to work very well. As your demand increases, you're going to need to talk to the Hugging Face team to work with them to make sure you have the right equipment, the right hardware, and the right scaling. But out of the box, this is going to work very well. We also, of course, have our Mistral 7B01 instruct model. The idea here is that we're going to use this text generation interface or inference container, which is optimized for text generation. So, when it comes to the idea of inference optimization, we really want to rely on tools like TGI or others in order to ensure that we're serving our requests as efficiently as possible. This is running on just one GPU, A10, which is $1.30 an hour. So not so bad at the end of the day. So that's great. We've got these endpoints, and we can interact with them through LangChain, which is great. You can see here a Hugging Face inference API embeddings, right? Where we pass in our API key and our API URL. So that's how we create our index. Now that we have our index, right, we want to go ahead and we want to leverage it in a chain, and then we want to just have all of the chain happen, for us with LangServe. And so we can do that by a number of different methods. The method we went with today is just the kind of simplest method, which is to just instantiate our chain inside the server, though we could instantiate our chain inside a different folder or directory, and I'll point out what that is in just a moment. But you'll notice that we have our Hugging Face LLM, which is just going to be running a Hugging Face endpoint with this endpoint URL, with our token, which we're going to pull from the end, and then the task is going to be, of course, text generation. Our embeddings model will also be talking. It's the same we set up when we actually created our vector store. The API URL is the same. The idea is this is what we're going to use to embed all of our queries as they come in. We're going to load our face vector store from local. So we're pointing it to the directory where we saved it, and we're passing in the same embeddings model to ensure that it's going to work and be consistent, right? We have to use the same embeddings model that we use to embed our original documents to instantiate this vector store, or else we're going to run into some issues. And then we're going to set it up as a retriever, classic. We'll create a simple RAG template, right? Use the provided context answer, use the question. If you don't know the answer, say you don't know. And then, of course, we have our context, which is going to be our retrieved context, and we have our question, which is going to be our user's question. From there, we can save that template as a chat prompt template, and then we can build our simple chain. We're going to use a pattern found on the LCEL documentation, which is that the first part of our chain is going to take a string, and it's going to use this runnable parallel option to run in parallel our retriever, which is going to retrieve information for us, and then passing through our question. Once we have our context and our question, we're able to chain that piece of information into our prompt, which will use context in question to format the context in question fields in our RAG prompt. Then we're going to chain or pipe that into our LLM, which is hosted on Hugging Face inference endpoints. And then we're going to chain or pipe that into the string output parser. I'm sorry, I'm clicking on these things and they cause that window to pop up. The idea here is that we're going to pass in a string, then chain that string into our prompt with our context, then chain that into our LLM, and then chain that into a string output parser, which just returns it as a string. We have this app get at root, and that is just going to be redirecting to docs. I didn't write this. This was boilerplate from the server.py. And we're going to add our route. We're going to add a route to our app. You can see we've defined our app up here. And then we can add our chain, which is the chain we created here. And then we can add our path, which is just where we want this chain to live. So we're going to add it to /rag in this case. And that's it. Now you might be wondering, boilerplate, how did you get all this boilerplate, right? Like that sounds dope. And it is. All you need to do to get the boilerplate is run LangChain app new and then wherever you want it to live. And that's going to create all of this for us. It's going to create our server.py. It's going to create our Docker file. It's going to create our packages directory, and as well as our poetry with some basic, dependencies that are needed to run the actual LangChain and LangServe backends. You'll notice that we have this packages directory, though. So we could, instead of using the chain and server.py, we could instantiate in our packages directory, and then we could use that as a template going forward. Say we wanted to have like a template application, we could use that, as well as we could use a number of templates from LangChain. LangServe has a ton of templates that you can find by looking through their docs. Absolutely incredible. They've done a ton of work to make this as easy as possible for us. Once we have our chain and we've added our route, we're going to go ahead and we're going to use this command, LangChain serve, to launch the web server. And that is it. Now, if you were using, say, a GCP environment or AWS, you would instead just, push the container and then have it build, in which case it will serve it at the end of the build process when we run the container. But for the local development, all we have to do is LangChain serve, and then we can go to our localhost 8000 /rag. Remember, this is the path that we put our chain on, and then the playground. And you get a couple things when you LangChain serve. Number one, we get docs. All of these docs were created entirely by LangServe. I didn't create any of them. We have invoke, we have batch, we have stream, we have stream log. These are incredible tools, right? They really help simplify creating tools with our chains. So this API is, we can access this API in a way that other tools would expect. And then we also have access to our schema. So our schema is going to be, what we expect this to be in, and then what we expect this to be out. So you'll notice that we have the response body. We have the type that's expected is a string for our input schema. Our output schema, we can do the same thing, and we can see that we're going to return type string. So this is really helpful when we're actually integrating this with a web application, right? The fact that this is automatically delivered to us means that I'll zoom in a little bit. I'm so sorry. I just noticed it's very small. So the idea is, right, when we execute our output schema, we can find exactly the output key and what type it's going to be in, right? So the idea is that we're going to be able to very quickly develop an application for this, because we don't have to wonder or worry about what the inputs or outputs are going to be. So it's very, very, very handy. Really a powerful tool. And then, of course, it comes with this playground where we can ask cool questions. We can say things like, how do I actually build the Docker container once I'm done? So we can ask this question and hit the start button. You'll notice that we have these intermediate steps that we talked about at the beginning. These intermediate steps are very powerful. They not only show us exactly what's happening, but they also show us exactly what order it's happening in, what documents or source documents we have, right? So imagine that you're able to just intercept these and then build a source, list for your users. We can also see the messages after we've formatted our prompt, right? So this is our formatted prompt. We can see what the Hugging Face endpoint comes back with. We notice, because this is a relatively naive, retrieval pipeline, it's not quite sure how to build a Docker container. So we would need to make our retrieval pipeline a little bit more robust. But the idea is we're able to ask these questions to get answers from the actual LangServe docs, right? What package manager, gotta learn how to spell, manager does LangServe use? This is, it might find this response. Package manager is a little bit loose, but the idea is, again, we get this response. LangServe uses poetry as its package manager, so it's able to infer from the context, which package manager it's using. And again, these endpoints are the models being served from Hugging Face inference endpoints, and this was all set up with just typing in LangChain serve, right? And we got all of this. We can also do the classic. What is the airspeed? Airspeed velocity of an unladen swallow, right? Just to see what happens, just to see what it's going to tell us. It shouldn't know, right? So we'll hope to say, yeah, it does not know, but it knows it's a reference to the joke, so that's great. And that is basically LangServe. I mean, all we have to do is go to our server.py, add our desired chain, and the chain can be as straightforward or as complex as you need. Then add that chain to a route and then serve it. And we get all of what you just saw, all that functionality completely out of the box by typing in LangChain serve. So it's a very powerful tool, especially if you're on a small team and you need a way to get your prototype from the prototype stage to something that you can host on whatever your favorite cloud provider is. LangServe is absolutely a legendary tool for this. So with that, I will pass it back to Greg.
Yeah, Chris, that was awesome. LangServe really does seem to just make it so easy to deploy these things to production. I mean, top level on their docs, it's all about those one-click deployments, as it always has been, since the days of ML ops here. We need those one-click deployments, and it's getting easier and easier with LLMs. Awesome to see how we can deploy LangChain chains as REST APIs. It's really cool to see that integration with FastAPI. Interested to dig in a little bit deeper on that myself in the future and maybe provide some more detailed content for folks out there. Also, in case you missed it, Chris did leverage a Hugging Face inference endpoint with AWS SageMaker here. This sort of allowed us to make this a little bit more of a scalable production application. As sort of foreshadowing maybe one of the top questions in the Slido today. And so overall, we saw that we could build out this sort of RAG application where we're leveraging Hugging Face embeddings. We're leveraging the latest and greatest from Mistral. We're actually deploying that with an AWS SageMaker endpoint through Hugging Face, which is really cool. We built this thing of LangServe docs within a Face database, and we were able to get really great performant results on asking very specific questions about how to build things with LangServe. So finally, in conclusion, LangServe just works. Pick it up, go start using it today. I mean, it's clearly leading the way as sort of a best practice tool in this space. It's at the right layer of abstraction, and it's certainly something we're going to be spending more time with moving forward here. It has that really sweet playground you get, and it shows all the intermediate steps, really taking it to the next level. Again, if you're going to build with an open source model, it's probably going to be Mistral 7B today. Stay tuned on those mixture of experts models. And then deploying open source RAG to a production endpoint has never been easier than it is today. So, start building, shipping, and sharing. Finally, the last thing that I wanted to mention is that we are going to tackle the highest level of abstraction in this hierarchy of LangChain. We're going to do that next week, and we're going to talk LangSmith on December 20th, 10 a.m. Pacific. We'll drop the link in the chat so you can join us, hopefully, for that one as well, if you enjoyed today's presentation and demo. With that, we'll go ahead and open up for Q&A, and we'd love for you guys to throw some stuff you want to talk about in the chat, in Slido, and we'll field it as it comes. So, Chris, welcome back, man. I've got the first question here about scaling. How does it scale in terms of concurrent sessions from Alex? Will it work with 1,000 people using my RAG app at the same time? Where's the bottleneck?
I mean, so it can definitely scale. It is using FastAPI, which we know is built exactly for kind of these performant Python backend situations. In terms of the maximum or how hard do you want to hit this thing? That's going to be up to the equipment you put it on. That's going to be up to a lot of different decisions that you can make. I would say that FastAPI has been shown that it can scale to the moon. So there's no reason this would be different. It's going to rely a lot on your kind of your actual model endpoints. That's gonna be the bottleneck. So where you're gonna see the largest latency contributors is going to be when you're actually waiting for models to respond. Other than that, yeah, it work with 1,000 people using it on the same server as long as your model endpoint can keep up. Yeah.
As long as the model endpoint can keep up. So that sort of AWS model endpoint was kind of important there if you want to go to 1,000. And hey, good luck getting to 1,000. If you got 1,000 already, that's cool. But yeah, build it out one step at a time and build it until it breaks. That's what we love to see. So next question is talking about GPU size. How do you know how big of a GPU you need for the deployed model? And maybe we can take Mistral 7B that we use today as sort of an example case.
You're going to need a bigger GPU than you probably expect for most of the time. It really depends on how you're serving the model. So, when it comes to things like, say, for instance, I'm trying to think of the best way to phrase it, but like, if you're using TGI, for instance, what you have to be aware of is that you need to be able to fit the model and whatever requests are coming in. So you're setting the maximum request is huge. So you make sure your card doesn't get bogged down. When it comes to handling parallel requests or batch requests, it's going to take that much more memory overhead. And so it really comes down to a number of decisions you can make, which makes it very variable. I mean, if you're using these things like 4-bit quant or AWQ or GPTQ, you're going to be able to fit a very big model on a much smaller card than you expect, but it comes down to a number of decisions that you have to make as the user. I would say that you shouldn't need insane hardware if you're using these quantized models. And for the actual LangChain application, you don't need a GPU at all, of course. It's all CPU processes that are happening. So unless you're doing some kind of local to the application embedding with GPU, you don't have to worry about it.
Okay. All right. We got a cost question coming up next. From a cost point of view, when would you consider hosting embedding and LLM models like Mistral versus just using providers, hitting APIs like Cohere, like OpenAI, paying for usage?
When you have saturated when you have enough requests that you are saturating hardware reliably, because you're going to wind up paying for hardware by time a lot of the time, right? So the amount of time it's running, and if your GPU is not doing inference, but you're paying for it, then your money is vanishing. I mean, scaling can help with this, but in order to reduce cold starts, you're going to need to have some amount of equipment running basically all the time. When you're at the point where you're basically saturating that equipment, I think maybe that's a good checkpoint or milestone that you could consider. But other than that, honestly, the actual cost analysis is probably something that you're going to want one of your teams to work with you to decide. If you're sending a lot of smaller requests to GPT, or say you're using a gradient kind of a platform, you're paying per token. Well, that could be very cost effective, right? And so it really depends on what your scale is and how much you're charging people. And at the end of the day, the way I think about it is, once I've got to the point where I'm saturating my equipment, where I'm saturating the GPU, it's always doing stuff basically. Then I'm feeling, or at least it's predictable time ranges, then I'm feeling better about self-hosting. But for the quality difference between an OpenAI versus a Mistral, if it's cheaper, feels like you're probably gonna want to do that if there's no PII concerns or a specific reason you need it on-prem. And one last point on that, if you are getting to the point where your providers can't keep up, which does happen, right? OpenAI, you'll just kind of cap out, and OpenAI is no longer good enough. It can't keep up with your requests without moving to their kind of enterprise solutions. Then it becomes a business decision. I mean, it's just, do you want to slam down the cash for for these enterprise solutions, or just run it yourself? And that's going to be up to you and your team.
Yeah. I like this sort of bounding of when you run out of when you're no longer gonna cold start because you're hot and you're on all the time, maybe that's one checkpoint. And then if you're so on all the time that you're running out of even the provider and their ability to serve you without slapping down that sweet cache at the enterprise level, then that's sort of the next big scaling checkpoint. That's super useful, and yeah, that's a great point. So Juan, one of the latest legends of our community, shout out to Juan out there, asks, so LangServe is similar to Chainlit, right?
I mean, no. That's an interesting question. No. So LangServe is complementary to Chainlit, right? So you could use Chainlit with LangServe as like kind of the front end, but LangServe is intended to be the back end, right? So it's like the playground looks good and it works, but like we're not shipping the playground to our users, kind of thing, right? So
yeah,
LangServe is meant to be the back end for these AI powered application solutions. It's not intended to be the front end. So in the fact, or from the point of view of like, well, Chainlit's the front end for these applications and LangServe is the back end of these applications, then they're similar in that sense. They help us abstract away a piece of the full stack to be in our wheelhouse, which is dope. But I would say that more generally, they're pretty different in terms of creating a fast API backend versus creating a beautiful front end for your applications.
Yeah. It reminds me of when we were teaching ML ops, and we can use the docs on FastAPI as a sort of UI as a developer, and oftentimes we do as we're building. But yeah, like our user would never want to see all those intermediate steps the way we would. They just don't care, right? And so yeah, I like that sort of distinction of it's more like that FastAPI docs backend, and it really is that at another layer of abstraction. And so yeah, great question, great discussion starter, question one. Any stepwise process on how to use LangServe and LangSmith? This one's a little ambiguous.
It's easy. You provide your LangSmith API key when you're creating your LangServe application, and that is really how easy they made it.
Okay.
At that point, you can go to LangSmith and see your LangServe application, motor in, seeing all the intermediate steps, seeing everything that you'd ever want to see, getting those latencies, those token costs. It really is. I mean, they're making the tool easy to use. That's as simple as it can be.
Yeah. And that's sort of, I think, the line we're trying to draw between this week's event and next week's event too, is sort of try to show exactly where that fits in within the broader context of LangSmith. So yeah, I appreciate that question because it'll definitely guide the story we tell next week. All right, we're going to keep moving down here. How did you connect the LangChain documentation, that LangServe documentation, to the model exactly?
Oh yeah, absolutely. So that was the index that we created. So it's in the create index Jupyter notebook in the GitHub repo that we shared. Basically, the whole idea is we're just loading the repo, then we're loading all the documents in the repo, and then we're chunking those documents. Typically, we do this with like a PDF or whatever like this, but in this case, we're doing it with code, READMEs, and other such materials.
Yeah. Okay. I don't know if you're ready for this one, Chris. This is Mama Peep asks, Chris, what do you see as the ultimate business model for a contractor once I can use this program?
Man, if I knew that, right? I'd be telling a lot more people.
Guys that live it, right?
Yeah. I mean, you can do anything with these applications right now. And I think in terms of business model, you can be very creative and inventive. And, it's all how you add value to people. And then from there, the rest should kind of do itself. But yeah, if I had a answer for this question, I think I'd be telling people, you know.
Yeah. Ultimate business model is AI Makerspace's business model. Actually, everybody, tell your friends. Quick follow up, Maine. We have some great starter resources for you if you're looking to get into this space. We've got some great things on our GitHub, and feel free to just DM us on LinkedIn after, and we're happy to follow up with you and get you started down the path. Okay, so let's see. We've got this next question, which is, I'm trying to clarify this one. Yeah, I don't know. That one's a little bit off. I'm not sure that one's going to make sense. What's the difference between the embedding model and Mistral? And when does the embedding model come into play?
Yeah, so Mistral is a large language model. It's very good at producing text. It's very good at making text from text. That's this whole thing. The embedding model is very good at converting text information into a dense vector representation. That dense vector representation is going to capture certain information about the text, which we're commonly referring to as semantic information, right? So the idea is that our embedding model helps us turn all of our text into numbers, and we can use those numbers and the fact that they contain semantic information to find relevant text based on its number, right? So the kind of very loosey-goosey way to conceptualize this is that we give like an ID to a piece of text in number form, and then we can use that to search up similar IDs, right? So that's the basic intuition, whereas the language model is what we actually use to generate the text. They don't have to be the same. They can be like your embedding model and your text model can be totally different, as they're in this case. They can be from the same family. It doesn't matter. As long as you have some way to turn your text into numbers so the computer can search through it efficiently and quickly, and then as long as you have some kind of process to generate text based on a prompt, you need those two systems, but they can be like all kinds of different things at the end of the day. But the big difference is that one is used to encode information and the other is used to generate text.
Encoding versus generation. Yeah, and we've got sort of a great high-level overview. Just drop the link in the chat there for you, Eider, to sort of check out. I know we went fast today walking through RAG because it really wasn't the point of the day. But if you really want to slow walk through, that's a great place to go ahead and start. Chris, man, thanks for the demo. Thanks for the Q&A. Appreciate it. See you soon, man. Time to wrap up. Thanks, everybody, for joining us today. This brings us to the end, but only for today. Join us next week to talk LangSmith on December 20th at 10 a.m. Pacific. We're going to dive in to the next layer of abstraction in LangChain, and it also works surprisingly well. Last up, we want to just tell you that next month on January 9th, we'll be launching LLM Engineering Cohort 2. We've made a ton of improvements to the course. It's all about LLM architecture and what's going on inside of the LLM. And of course, we need to add and talk about mixture of experts models and the latest and greatest things coming out from folks like Mistral in that course as well. So soup to nuts LLMs, that's what LLM engineering is all about. And then if you're into it, you want to learn more about deployment, LangServe, LangSmith, these types of toolings, LLM operations is going to kick off on February 13th, where we'll be launching cohort 4 with the latest and greatest tools for really shipping and sharing LLM applications like you see us doing today and like we'll do next week, and we'll continue to bring to you weekly on YouTube. So if you want to kind of get into the AI Makerspace community a little bit deeper without going in full bore on a super accelerated course, check out our Discord and, jump into a community session. We're having them weekly. We're having them all the time. We'll throw the link for the Discord and for our community calendar in the chat. We got amazing folks. We've seen a lot of them in the chat here today. Shout out to everybody that we saw, Harpreet, Juan, Mert, and others. They're absolute legends in there, and we'd love to hang out with all of you guys more and more as we move forward. So that's it for today. Until next time, keep building, shipping, and sharing, and we will do the same. See you soon, everybody.